Over Germany, American bomber crews watched the horizon for fighters that could not stay. Then came a sleek American machine built because Britain had asked for it, transformed by a British engine and mass-produced in the United States. But the first Mustang was not the legend. So, what actually closed the escort gap? And did one fighter really break the Luftwaffe? The short answer is that no single country, engine or design feature did it alone. Britain supplied urgency, combat experience, and the engine experiment. North American supplied an exceptional airframe. Packard production, extra fuel, drop tanks, and a new escort doctrine turned those pieces into a weapon system. That combination arrived after unescorted bomber formations had paid for the missing range in aircraft and men. The story begins, therefore, not with an American legend, but with Britain running out of time. In the spring of 1940, Britain expected a long air war and needed more modern fighters than its own factories could quickly supply. The British Purchasing Commission went to North American Aviation, hoping it would build Curtiss P-40S under license. North American's president, Dutch Kindleberger, offered something bolder, a new fighter. That offer was risky. North American was respected, but it had never produced a frontline fighter of its own. Its team, led in design by Edgar Schmood, had to turn British requirements into metal while the Battle of Britain was approaching. Schmood's name matters, but the Mustang was not one man's sketch. It was a compressed industrial team effort. And the famous stopwatch needs careful reading. The famous number needs care. North American promised a prototype on a 120-day schedule. The Bear NA-73X rolled out on September 9th, before its engine was ready. The first flight came on October 26th. Speed of development was extraordinary, but a prototype on the runway was only the opening bet. The design had a thin, low-drag wing, a tightly wrapped fuselage, and a radiator installation under the belly. North American also used the hot air leaving the radiator to recover a little thrust, reducing the cooling system's drag penalty. The result was fast, clean, and unusually long-legged for its size. Yet the first operational Mustangs would reveal a ceiling, not of courage or design speed, but of engine breathing. Britain received the Mustang 1 with an Allison-powered 1710. At low and medium altitude, the aircraft was fast, stable, and useful. The RAF did not regard it as a failure. What limited it was the production engine's single-stage supercharger. As altitude increased, the air thinned. The engine could take in less oxygen and power fell sharply. RAF evaluators could see both truths at once: an excellent airframe and a high-altitude mismatch. Below roughly 15,000 feet, the Mustang's speed and range made it valuable. Above that, it could not yet challenge the best fighters on equal terms. That distinction explains why the first Mustang never became the famous bomber escort. It found a different war. RAF Mustangs flew low-level tactical reconnaissance and Army cooperation missions where speed near the ground mattered more than power at 30,000 feet. Pilots crossed the coast, photographed roads, railways, and troop movements, then used the aircraft's low-level performance to get home. This was useful, dangerous work, just not the mission that would make the Mustang immortal. In November 1943, an RAF Mustang 1 could still be found banking over France on reconnaissance. The airframe, had demonstrated range, control, and low drag in real operations. The unanswered question was whether another engine could carry those qualities into the bomber stream's altitude. At Rolls-Royce, test pilot Ronald Harker and engineers proposed the obvious but difficult experiment. Put a two-stage Merlin into the Mustang and see whether the airframe had more to give. The Merlin's advantage was not simply more horsepower. Its two-stage, two-speed supercharging kept feeding the engine dense air far higher above the ground. Rolls-Royce converted several airframes into Mustang X test machines. The installation demanded new cooling arrangements, propeller matching, and careful flight test. This was engineering, not an engine swap in a weekend. The result answered the altitude question decisively. The Merlin did not redesign the Mustang's wing or create its fuel volume. It unlocked an airframe that was already aerodynamically efficient, allowing that efficiency to survive where American bombers fought. British tests and parallel American work converged. Packard, already licensed to build Merlins in the United States, supplied the V-1650 that American factories could produce in wartime numbers. In the museum's test summary, the Merlin Mustang reached 441 miles per hour at 29,800 feet, about 100 miles per hour faster than the P-51A at that altitude. That is the transformation the legend remembers. Production turned the experiment into the P-51B at Inglewood and the near-identical P-51C at Dallas. The B and C had the high-altitude engine the escort mission required, but their framed canopy limited rearward visibility, and four wing-mounted machine guns could suffer feed problems under high-G maneuvers. Those shortcomings would be improved. The more urgent problem was getting enough Merlin Mustangs to England and giving them enough fuel to stay with the bombers. Because while engineers solved altitude, bomber crews were discovering what happened when escort fighters turned for home. 8th Air Force doctrine expected tightly packed heavy bombers to defend themselves with overlapping machine gun fire. Early escorts helped near the coast, but P-47s and P-38s initially lacked the combination of range, availability, and reliability for continuous deep cover. On August 17, 1943, the Regensburg-Schweinfurt mission lost 60 of 376 bombers. The force returned to Schweinfurt in October because the ball-bearing industry remained a priority. Weather delayed the escort rendezvous. German fighters attacked in repeated waves, using rockets and heavy cannon to break formations before closing in. For men in damaged B-17, the argument over escort range became brutally physical. On October 14th, 291 B-17 were dispatched toward Schweinfurt. 60 were shot down. 17 more landed only to be written off or scrapped, and 121 needed repair. The missing escort was no longer an abstract argument. Roughly 600 airmen were lost over enemy territory on that mission, killed, wounded, or captured. The 8th Air Force suspended comparably deep penetrations until stronger escort could be assembled. This is why the Mustang story cannot be told as an engineering beauty contest. Its fame grew from a specific operational emergency. Daylight bombers could hit Germany, but could not repeatedly survive the journey without fighters beside them. The requirement was not merely speed. An escort had to climb with the formation, cruise economically for hours, fight at altitude, carry enough ammunition, and still bring a tired pilot home across the North Sea. The Merlin answered only one part of that list. The next answer was measured in gallons, tank plumbing, and disciplined fuel management. So how did the Mustang finally carry protection all the way to the target and still have fuel for combat? The Mustang began with 2 wing tanks and an efficient cruise. Later, B and C aircraft added an 85-gallon tank behind the cockpit, increasing internal endurance but shifting the center of gravity aft when full. Pilots normally burned fuel from that rear tank early. Under each wing, disposable paper or metal drop tanks added still more reach, then could be released before combat. This was not glamorous technology. It was plumbing, supply, weather calculation, and thousands of correctly filled tanks waiting at English bases. A P-51B could reach an escort radius of roughly 650 miles. With the later fuel arrangement and external tanks, the 8th Air Force could plan on about 850 miles by March 1944, enough to turn Berlin from a handoff point into an escorted destination. Range also had to be used differently. In January 1944, Jimmy Doolittle took command of the 8th Air Force. Close escort remained essential, but fighter leaders increasingly freed escorts to range ahead, attack German formations assembling for interception, and pursue them toward their airfields. The P-51D did not invent this reach. B and C models had already escorted bombers deep into Germany. The D refined the package: a bubble canopy for better visibility, 6 half-inch machine guns, improved ammunition feed, and on many aircraft, a more stable fin fillet. Nearly 8,000 D models were built. Production scale mattered as much as the shape of the canopy. Packard and Continental produced more than 55,000 American Merlins in the museum's accounting, while 2 North American plants turned out B, C, and D airframes. By then, the public face of the Mustang was the clear-canopied P-51D, even though the escort breakthrough had begun earlier. The mission now worked as a relay and a hunt. Fighters met the bomber stream, covered successive legs, and used their remaining fuel to contest the air around the target. The question was no longer whether escorts could reach Germany. It was what constant escort pressure would do to the Luftwaffe. During Big Week in February 1944, Allied bombers struck aircraft plants and related targets across Germany. American heavy bombers flew thousands of sorties and still suffered serious losses. The campaign was not a bloodless Mustang victory parade, but escorts forced German fighters to fight more often, farther from favorable bases and under growing pressure before, during, and after their attacks on the bombers. That multiplied the cost of every interception. The National Museum's Big Week summary estimates that the Luftwaffe lost about 1/3 of its available fighters and 1/5 of its veteran fighter pilots. Definitions vary, but the direction is unmistakable. Trained experience was being consumed. By July, Mustangs from Bottisham could be photographed in a polished formation that made the new reach visible. Yet victory credits need care. The USAAF credited P-51 units with 4,950 enemy aircraft destroyed in the air in Europe. These were wartime claims and credits, not a modern audit of every wreck and every opposing report. The Mustang's real strategic value was less cinematic. It made repeated deep daylight operations more sustainable and helped force German pilots into an exhausting series of unequal choices: attack the bombers, evade the escorts, or defend their own airfields. It also served beyond the 8th Air Force. The 332nd Fighter Group flew P-51s from Italy on long escort missions. The Tuskegee Airmen's record reminds us that the system depended on pilots, crew chiefs, armorers, and fuel crews working under pressure. and for Black American airmen inside a segregated military that doubted them before they flew. Their P-51s were not talismans. They required maintenance, navigation, formation discipline, and decisions about when to stay with the bombers and when to attack. The aircraft amplified trained people. It did not replace them. A crew chief closing a canopy is as much a part of the legend as any victory marking. And the Luftwaffe's decline had other causes: fuel shortages, shrinking training time, attacks on industry and transport, pressure from other Allied fighters, and combat on multiple fronts. The Mustang mattered because it connected deep escort to that wider pressure, day after day. Was the Mustang the best fighter of the war? That question sounds precise, but it hides different jobs. A P-47 could absorb punishment and excel in a dive. A P-38 offered twin-engine range. Spitfires and German fighters had their own advantages. The Mustang itself demanded respect, especially with a full rear fuselage tank. The manual warned that more than 40 gallons behind the pilot shifted the center of gravity aft enough to restrict aerobatics. Its liquid-cooled engine could also be disabled by cooling system damage, and no fighter was immune to weather, flak, or pilot error. What the Mustang did exceptionally well was one decisive task: carry a pilot far into enemy airspace, fight effectively at bomber altitude, and return on a fuel plan an enormous Air Force could support. That is a stronger historical claim than calling it unbeatable. The honest formula is not Merlin equals legend. It is British urgency and combat feedback, an American low-drag airframe, a two-stage engine, Packard scale production, more fuel and drop tanks, and a doctrine willing to use the resulting reach. Remove any one of those pieces and the famous story changes. Without the Merlin, altitude remains the weakness. Without tanks, the escort turns back. Without factories, too few aircraft arrive. Without doctrine, range is present but not fully exploited. The P-51 continued into the Korean War as the F-51, where its range and payload were useful, but its vulnerability to ground fire again proved that legend never meant invulnerability. In Korea, the same airframe served a different mission and faced different risks. The legend is real. The miracle is the combination.